Hello, my name is Michael Feist. I'm the Engine Test Lab Manager, and today I'll take you through a brief tour of ETL3. This is the newest of our 3 engine test labs. ETL3 was commissioned in 2014. It has 3 engine test cells, a powertrain test cell, and a climatic chassis dyno, and you'll get to see examples of each of those today. So as you go through the tour, I want you to kind of observe the increased level of integration that you see in each of the test facilities. So now we're out here at test cell 10, and I'm going to kind of walk through some of the major hardware components of a test cell and how it operates, and then we'll talk about some of the key tests that we run here in the test lab. So the heart of the test cell is the dynamometer. That's this big blue box in the back of the cell. And the dynamometer is responsible for absorbing power from the engine and delivering power back to the engine. So you could simulate a vehicle driving up a hill at full load or going down the other side of the hill with full engine brakes. The dyno is an AC motor, and it can convert all of the energy from the engine into electrical power that's then pushed back onto the grid, and that helps offset some of PTC's electrical consumption. Also shown in the test cell, there's a large pipe feeding combustion air to the engine. This is how we measure and control the temperature and humidity of the air that the engine is consuming. Shown on the side of the test cell is a fuel flow meter, and that's responsible for conditioning the fuel temperature and pressure, as well as measuring the fuel going to the engine. The test cell also has sophisticated ambient air control, so we basically are controlling all of the environment around the engine, and this ensures that the testing that we do here is precise and repeatable, so that engineers can ensure that they're going to get the same test result here as they would in a different test cell. At PTC, we actually have 11 test cells total, including ETL 1 and 2, and all of the test cells are basically the same. We do have 2 test cells that are used for EPA certification, and we have 1 test cell that's used for altitude and temperature extremes. So PACCAR globally has 46 engine test cells, with the remainder of those being at DAF in Eindhoven. So shown at the end of the hallway, we have raw exhaust gas analyzers, and those are responsible for measuring regulated and unregulated pollutants by the EPA. So a lot of the work we do here is to ensure that the engines that we sell are compliant with EPA and CARB protocols. Other key projects that we run here are durability projects, mainly focused on the customer, trying to make sure the product is durable and robust. So for example, we can run the valves over very aggressive cycles, and we disassemble the engine at the completion of that test, and we look for any wear items or possible problems. Another example of a durability cycle would be our thermal abuse cycle, where we have large tanks of coolant under the floor, one with very hot coolant and one with very cold coolant, and we can alternate the hot and cold coolant supplied to the engine, and this is important to look for thermal stresses or cracking. Other testing that we do here, we have a competitive engine benchmarking program, so we're actually buying the customer's product and bringing it into the test cell and reverse engineering and testing the product to make sure that we're matching or exceeding all of the customer's performance criteria. Other key work that we do here in the lab, we typically have 1 or 2 cells running current product support, and this is to support the vehicles that are currently in the field. For example, if a customer has a problem with a specific truck, we can send engineers to their facility or their site, and they can record data from that vehicle's operation. Then we can bring that data back and replay the same issue in the test cell, and that helps engineers quickly resolve customer issues that they're seeing in the field. We also have some advanced technology projects that are currently running, and that's basically focused on meeting future emission regulations, as well as improving fuel economy for the customer. So the difference between the powertrain cell and an engine cell is that now we're testing a more integrated product. We're testing the engine, the transmission, and the drive axles. So in terms of hardware, the powertrain cell has 4 large dynos plus gearboxes, as compared to the engine cell's 1 small dyno. And this is necessary to absorb the large amount of torque at the wheels. So the engine can make about 2,500 Newton meters of torque, but when that torque gets multiplied by first gear in the transmission plus the axle, that can be up to 50,000 Newton meters per wheel. So that's why the facility is so much larger. This powertrain cell is fairly unique in the fact that it can simulate a fully loaded truck driving from launch all the way to highway speeds. Many other powertrain cell configurations cannot hold the vehicle back in first gear, and so they actually have to skip first or second gear. Key testing that we do here in the powertrain cell. Obviously, we're working on integration of the transmission with the engine. So PACCAR recently released a very successful automated manual transmission, and that transmission spent about 2 years of its infancy in this cell as calibrators were working on optimizing shift calibrations for performance, drivability, and fuel economy. Also, engineers spent a lot of time working on predictive features in this cell, such as predictive cruise control. And this test cell is very good at accurately measuring fuel consumption, so calibrators can make a small change to the calibration and then measure incremental changes in fuel economy with this cell. Another key advantage to this cell is it can perform greenhouse gas emission certification for CARB and EPA. This is going to be a key benefit in generating credits for PACCAR.